are cold and dark at the gate. Before we power up, I'll show you a few click spots first. There are a couple hidden ones. This one here will get rid of this center bar if you fly in the 2D cockpit, or toggle it on and off. A little next to it is the backup compass. You can bring that up. This big blank area down here is how you choose, or one way to choose the panels. Rather than little buttons, there are little pictures of the panel. You have an aft overhead, the main overhead, and at the lower left of the main overhead you can bring up a mini panel that you use for starting, especially. Toggle that on and off. Captain's panel, first officer's panel, center pedestal. This little white panel is kind of a fake panel, but it's the flight data, takeoff data and landing data that you need for the FMS. You can also jump straight to some of the panels, well, first through a shift number key, or there are some more hot spots here. This will go to the overhead panel, and then at the top right of most panels, even though there's no X, you can still click it and that'll close it. You can move over to the first officer's panel by clicking on the first officer's CDU. This is used, you can fly online with somebody else with this aircraft, but even if you fly alone, you still have to come over here sometimes because the hydraulics are only over here and some of the nav lights, so you do have to use this panel briefly. Go back to the captain's panel by clicking on the captain's CDU. You can also bring up the CDU by clicking on it and get access to your FMS. So let's start by going to the overhead panel where we'll power up. In the course of powering up, I will explain all of the systems and pretty much all of the buttons and switches. So whether you start cold and dark or you start already powered up, you're still going to want to go through everything systematically and make sure it's all set correctly. So this is the main overhead panel. It's divided into sections. Starting at the top left, this is the electrical system and the APU over here. This section is the fuel tanks and starter to start the engines. Down here we have ice protection, which is pretty important for the Maddog. It has its own icing simulator above and beyond what FSX already does, so it's important to have the icing set right if you expect icing conditions. Over here is the pressurization air conditioning system, which is fully simulated. Pretty much every switch is fully simulated and has an effect. So you do need to know how to pressurize. Then up here we have miscellaneous lighting control switches and just miscellaneous switches. There's an aft overhead. You never have to go there really unless you're going to test some systems. But you have your flight data computer controls. You have fuses. You can pull it and reset it with the right and left click, and fire detection system. So first thing we want to do is power up. This button here is the battery. It's not exactly labeled, or it's hidden, but that's what you flip on. And you click it again, and that will screw it in place so you can't accidentally bump it. We're going to start the APU to provide power. There's three main power sources. The engine generators. The engines are off now, so there's no power coming in, even though they're turned online. These lines here represent the left and right buses. There's an AC and a DC bus. Normally they're separate. You can connect them together with these switches, but normally you don't have to. But the three power sources, engine generators, APU, which you can put online even though it's off, and then external power. So the Maddog simulates an external power source through the add-on Maddog menu. And you go to ground communications, and they're going to be grayed out because we don't have power. And we'll get in how to enable those. So we're going to use the APU. I put it online even though it's not online yet. There's two switches associated with starting and shutting it down, the master switch and the fuel pump for the APU. That's the start pump. So you want to turn the start pump on and turn the master down to start and let go, and it'll release. Then you want to look up here to the RPM, and it should start to go. Sometimes it doesn't. If it doesn't, just toggle start again. But there it goes. Now, while we wait for it to power up, there's one more source of power, which is the emergency power, and it looks like it's in use, but that's just the graphic. It actually gets a little brighter if you turn it on. But this will pull electricity off of the battery and onto an emergency bus so that critical systems can be powered by the battery in case everything else fails. But if you don't have failures enabled, then you don't have to worry about that. So once this gets up to 100, the APU power available light comes on, and I already put it online, so it automatically kicked in. We now have AC power. There's one other main switch in the APU section, and that's the air switch. By default, that's off. You want to turn that on. The APU provides both power and air, and we use air pressure or pneumatic pressure to start the engine, as well as to provide the air conditioning when we are on the ground or heating. Okay, so my APU's on. I've turned the air on. Now I'm going to go systematically through each of the switches in what I recommend is the flow pattern you use. You can use any pattern as long as you systematically cover every switch and make sure that it's set correctly. So I'm going to go start up the top and go top down, left to right along the left half, then go across, and then go right to left, bottom to top here, go to the aft overhead, then we'll go down to the main panel. So starting up here, you never have to touch these. This is to disconnect the constant speed drive, but they're hidden under the plastic cap. The generators, even though the engines are off, you can put them on so that when the engines start, it'll automatically switch over to the engine power. These are listed in priority, so the engine generators are first priority, APU second, ground power is third. So if you have ground power on, but then you turn on the APUs, it'll automatically switch over to APU, and same with APU to the main engine. Now this switch is on norm. This is the APU reset switch. Sometimes when you start it, it'll get all the way up to 100% RPM, but APU power light won't turn on. In that case, you just toggle reset, and it should come on. So those are online. My APU's on, so I put these online. External power is not plugged in, so I have that off. Galley power, power to the back, you want to turn that on. Continuing across, these stay normal. APU's on, the air's on. The APU normal switch or econ mode, you never have to touch that. These switches here are really in case of a fire. Normally when you turn the APU off, it'll take about a minute to cycle down. There's a power down sequence and cool down and everything. But if there's a fire and you want to shut it off immediately, you would flip this switch down. That would also arm the fire agents, and you could extinguish a fire. Emergency power's off. Continuing down, all the pumps are off. We haven't started yet. Start pumps on because we're running the APU. Emergency lights, you need to switch to arm. No smoking and seatbelt signs on. Now the icing system, like I said, is important, and you always want to have the probe heat on. That's controlled by this switch. There's various probe heats and pitot heat, and windshield anti-ice. Even in the summer, you need to have those on, otherwise it'll give you a warning message down here in the annunciator panel. This is a multifunction switch, so if you turn it to any of these values, it'll turn all of them on. And plus you can look at particular temperatures for each of these, but you never have to do that. Just keep it on captain, and windshield anti-ice will turn on. During icing conditions, which is 10 degrees and below centigrade, you want to have your engine anti-ice on. Your airfoil icing is your wing anti-ice. That is run by air pressure, pneumatic pressure, bled off of the engine, so it'll actually affect engine thrust. So you don't want to just always put wing ice on. Only put wing ice if you're in actual icing conditions. So you're in precipitation or flying through a cloud, and again, you're below 10 degrees centigrade. Tail icing actually alternates. It'll spend 2.5 minutes de-icing the tail, and then another 2.5 on the wing ice. Maddog also provides ground de-icing accessible through the menu, and ground communications. You can get anti or de-icing fluid at the gate or on the taxiway. It'll simulate those trucks. I don't know if you see the trucks, but it'll apply a simulated de-icing fluid to the wings, and should last for about 45 minutes. Okay, continuing across, flight deck door, you can lock it or unlock it, and you'll get the warning message if it's unlocked. Windshield wipers. This is the part of the pressurization system, which I'll get to in a second. This is the annunciator test light. When you press that, you can see all the lights. This is also available on the main panel, mini panel. If you remember down here in the overhead at the bottom left, you can bring up this mini panel and then test all of the lights that way. Okay, back to the overhead panel, the pressurization system, air conditioning system. All right, these are the main switches to turn it on. We're providing air through the APU. Remember, we turned the air switch on. However, they're not coming through yet. We have to open the cross feeds, which we'll do toward the end. No, let's do it now. I'm going to jump ahead to the center console all the way at the bottom. These two white knobs are your pneumatic cross feeds. You have to turn those on, and you should just leave them on pre-flight, post-flight, during flight. There's no reason not to. But now we're getting pressure, you'll notice up here, so we're actually getting air, and it's going to, in this case, warm up the cabin. Normally you could leave the temperature knobs at auto. If you want to make it a little hotter or colder, you can click it to go to manual mode and then adjust the valve hotter or colder to blow more hot or cold air out. And then click it again to go back to auto mode. These three switches you never have to touch. It's for failures. That's diverts air from the cargo to avionics and overheat, override, but you never have to touch those. This sometimes you have to touch when you start up or in your normal flow. There's a primary and a standby system for the pressurization. If you go to standby, it'll turn these lights on, but also if you shut down power, it'll sometimes automatically switch to standby. So if these lights are on, just come over here, toggle it up and back down, and then click it. So now you're back on primary and the lights are off. The pressurization system works automatically. The long arm here and the outer dial is your cabin altitude. Of course, you never want it above 10,000 feet. People get hypoxic and can eventually die. So as long as your air is being supplied, it'll automatically pressurize, and you'll see this rise as you climb in altitude, and it'll descend as you descend. Before you get to your destination, you can, actually this is optional, but you can put in your landing altitude and landing altimeter. That's so it knows the outside air pressure, and you can open the doors properly. But even if you don't put it in, the doors will still open, so that's optional. So that's the pressurization system. Continuing up, again on the right half, going right to left, the ice FOD is a detector for clear ice when you're on the ground. So if you're taxiing and you forgot de-ice fluid, you'll get a message down here that says ice FOD. In fact, we'll test it, and you see ice FOD alert. It also says the system's inoperative. That's because it's in test mode. Put that back to normal. Now we'll skip down here. This is your alert annunciator, and normally in flight it'll be blank. You'll have no messages. You might have one message, but if you have a bunch of failures, you can page up and down through the pages with page up and down here, or you can divide it into sections. If you just want to see the electrical problems, click electrics. Just want to see the hydraulic problems, click hydraulics, etc. But normally they would be all black, meaning no warning messages. On the main panel here, this graphic, on the 2D cockpit anyway, this graphic is fake. It's just to let you know that there is a message. It'll always look like that even with one message. Or it'll be black, meaning there's no messages. But if this graphic appears, that tells you to look up on this panel to see what the real message is. So that's the annunciator system. Back to the ice fob, we've tested that. Logo light, it's daytime, so we'll leave that off. Mach trim compensator, leave that at normal. Max speed warning test, let's test it out.
Overspeed.
Stall test, there's 2 systems.
Stall. Stall.
Both work. Yaw damper needs to be on. Anti-skid needs to be armed. Your flight attendants, you can ding them, and it has a flight attendant simulator where you can go through the add-on menu and talk to the crew and tell them to start boarding, etc. That's optional. But they'll board passengers. It takes about 8 minutes. They'll open the doors, close the doors, and tell you when they're ready. Cockpit floodlight and thunderstorm lights. This will just quickly turn all the lights on. Otherwise, you can adjust lights with these knobs, and there's various light controls throughout the cockpit, but these control the overhead. And again, it's daytime, I'll leave them off. Circuit breaker light, standby compass light, wind shear test, let's test it.
Headwind, shear, headwind, shear, headwind.
And it says fail, again, because it's in test mode.
Tailwind, shear, tailwind, shear, tailwind, shear.
And ground proximity warning, we'll test that.
Glide slow. Pull up. Terrain, terrain. Pull up.
These work fine. Let's go to the aft overhead. Like I said, you never have to come up here unless you want to test things, but all these knobs should be up, and they are by default. All the circuit breakers are pushed in, and they are by default. And you can come up here to test the cargo fire, and that works fine. All right, that's the overhead. Now let's go below, and I suggest for the flow going left to right, and starting at the very left, which is the captain's side panel. So we'll bring that up. And actually, I'm going to skip ahead just a little bit and power up these so you can see the HSI. These here control the HSI, so by default, you probably want to put it on map mode. That's the normal in-flight mode. You'll want to click off the ADF, because I don't know anybody who uses ADF for navigation anymore, and no need to clutter the screen. The range is your discretion. These are filter keys for what you display on the map. You can leave, here's lighting controls alone. Again, it's daytime, but this will control the lights for captain's side. Now this is the radio panel, or the captain's radio panel. It's actually kind of important. By default, for some reason, they have the VHF nav receivers on, or going through the captain's headset. And that'll be really annoying in flight. If you happen to fly around a VOR, and you're in range of the VOR, you'll hear the Morse code in your ear and wonder where it's coming from. It'll drive you crazy. So you want to turn those two off, and then come over here to interphone. These switches are the microphone selector, and again, they have it selecting to transmit on the nav radio, which doesn't make sense. You want to put that on interphone and turn the interphone on. And that will enable your Maddog ground communications. You'll notice I can select them now. If either one of these isn't selected, you can't access it, and that'll drive you crazy too until you realize, oh, I have to turn that on. Now I can talk to my ground crew, connect the ground power and air conditioning. There's a pushback tool where you can choose a distance to go back and an angle. You can also use Shift P to stop it. So we'll cancel out of that. But that is controlled by this. And you can just leave it on for the whole flight. And that's this panel. So there's the side panel. Now we come to the main panel. Here I suggest right to left, top to bottom for the flow pattern. So starting over here, you want to turn the flight director on. Autopilot, these are all flight specific. We'll get that when we program the FMS. But you want to make sure the autopilot's off, auto-throttles off. Flight director's on. This is your nav 1 radio. The first officer side has the nav 2 radio. That's a little different than most aircraft. This is on the center pedestal. It's actually kind of handy, but that'll be flight specific. Your landing lights on most aircraft are on the overhead. Here they're right there, so that's kind of handy too, but those are off. You come down here, come across. You want to turn the power and brightness to these screens on. Come over here to the standby attitude indicator. You got to press it or click on it once. In that case, sometimes you have to do it twice until it's level. Down here is your weather radar. It does have a integrated weather radar. However, it's not accurate, so I don't use it. I put in a active skies radar on the lower console, which we'll get to, but it's at your discretion if you want to try to use it. Up here is your fire test. They call them the loops, fire detection loops. If I test that one, I see this light blinks, and I can test this one, and again the light blinks. This is your auto throttle you don't have to touch yet, your fuel indicator. Let's go over to the first officer's side. Again, this is moving the flow across. Coming across here, here's your hydraulic controls. All the switches should be up. So this is your engine-powered hydraulic pumps. The engines are off, so we have no hydraulic pressure. You actually want hydraulic pressure on the ground. I think the rear stairs need pressure to operate. So to do that, you put these switches on. This is the electric auxiliary pump. And these are designed to be on all the time, even with your engine pumps on, so that can just stay on during the flight and after the flight if you want. This is your brake pressure and emergency brakes pressure. Don't have to touch it. Come across here. I'll turn these on just for my first officer. Come up along here. Your nav lights are on the first officer's side. I put them in takeoff mode just so I don't have to come back to this panel. But you can just have your position lights, the red and green lights on the wings. But I put the flashing strobes on the ground. Again, just so I don't have to come back here. And then your rotating beacon light. You'd normally turn that on when you're ready to start the engines, but I just keep it on. That's up to you. So back to the captain's panel. One more panel to do, and that's the center console. Now this is a little different, or a little more cluttered than most aircraft. First of all, at the lower left here is your takeoff computer, and it's actually just a dial where you dial in your center of gravity, dial in your flap setting, and it'll move this little green tab here to indicate what stabilizer trim setting you need for takeoff. So 15 flaps is the normal amount. So we'll dial that in. The center of gravity number is from the loadout manager. You remember when we loaded the 60 people in front, 80 people in back, no fuel in the middle. It came up with a center of gravity number of 21.1. It will automatically set that correctly, but if you wanted to dial it in differently, you could do that. And that'll set the stabilizer trim. Normally we do this pre-flight, so this isn't a startup item. I was just explaining what that is. Okay, then you have the speed brakes. They're actually very effective in flight. These two levers here, you never have to touch. This is rudder hydraulics. You can leave it at the default. You can switch between manual or hydraulic powered. Fuel cross-feed lever, again, is up there for some reason. This is the pressurization wheel to let air in and out to pressurize the cockpit and cabin. You leave this by default. It's in automatic mode, but if you need to go into manual, you would click this yellow tab, and now you can move this wheel to let air in and out. Your flap lever and slats, it's a little different than most aircraft. The first notch, if you're going step by step like I do, increment and decrement, your first notch is slats. So it's actually flap 0, but that means slats are being deployed. And if I move this over, you can see the indicator down here. This is the slats indicator. Slats are retracted, so everything's dark. If they were deployed, this top light would be on. So again, the first notch is slats deployed, flap 0, then the next one will be flaps 11, 15, and so on. And retracting would be the opposite. You go back to 15, 11, flap 0, but slats still deployed, and then last notch would be slats retracted. Okay, continuing down here, you have the TCAS. It's a functioning TCAS, including resolution advisories. Are not very good, though. It also works online. Your TCAS range, I usually just turn it out to the max and test the TCAS. These are your COM radios. This is your main COM radio, then you have COM 2 and 3. So this is the main one you use. Down here you have lighting controls for the center console and also this pedestal. Continuing down, the auto brakes, you can put, I'm going to put in takeoff mode and arm them. You could do that later. Pneumatic crossfeed should always be up. We already covered that when we turn on the air conditioning. And there you have it. That's it for the panel switches and all the systems. And at this point, we're now ready to program the FMS and push back and start. All right, this is the flight management computer, or technically the computer display unit, CDU. When you click on it, this is the first screen you see. Now this is the Smith style FMS, Smith style FMC, that's also used on Boeing aircraft. So if you have any PMDG products, aircraft, you may be familiar with this. But it's a very old interface. It's kind of awkward. It was designed in the 1970s, actually. So the concept here is that you have a bunch of different pages, or top-level pages, rather. For example, this is called the ident page. And then each top-level page may also have sub-pages. So this is only one of one, but if it was, say, one of three, you could go to the sub-pages through the next page and go through them with next and previous page. Then you also have an index of the top-level pages. The lower part of the screen here, this little less than, means you press this button to go to the index page. I'd press this button to go to the position init page. And this lower right field is actually the page it suggests to go to next. So whenever you're on a given page, that's the one it suggests next. And the concept here is you type in things, and as you do so, it'll appear on the lowest line, which is called the scratch pad. Oh, that's not a good abbreviation. On the scratch pad, and then you copy from the scratch pad into a field by pressing one of the buttons next to the field. This doesn't have any data fields that we could copy to, but if this was a field, I would click that, it would copy from the scratch pad to that field. Likewise, I could copy from the field into the scratch pad by selecting the button, and that would copy it down. The clear key is basically the backspace. So as I'm typing things in the scratch pad, I make a typo, I would hit the clear. The delete key actually puts the word delete in the scratch pad, and that's how you delete a field. You would hit delete, the word delete would appear, you would then copy that into the field. That would actually delete it. So going up to the index, normally you wouldn't go here unless you wanted to skip around, but here's where you would see the different top-level pages you can go to. So we're going to go back to the ident page. Again, this is what it appears when you power up. This just tells you your current version, aircraft model. The suggest next page is the position init. We have to do three things. We need to initialize our position, enter our route, and enter our takeoff data. So the first thing, we have to initialize position. The Maddog, at least this version, doesn't have a GPS. It uses the old internal navigation that checks the VORs and so on to interpolate a position, and also internal sensors. So you have to calibrate it once a day maybe, or maybe before each flight, and that's what we do here. So you'll see two fields here. The dashes indicate it's optional, and squares indicate it's a mandatory entry. So to initialize a position, we have to put in some position. We could type it in, but there's an easier way. You go up here to reference airport. We're at Detroit KDTW. We would then type in a gate, and in real world it would look up in the database the lat long at that gate. Here it kind of cheats. It just gives you your current lat long. We want to copy this into this field, so to do that we select it, puts it into our scratch pad, and now we're going to select this one. It'll copy from the scratch pad into the field. We could also type it in directly, but it's a lot easier to do it just how I showed you. Okay, we're now initialized. Let's go to the suggested next page, which is to enter our route. So you see a bunch of fields here. Here's a mandatory field. It copied over our origin, Detroit, and our destination is going to be JFK Airport, KJFK. We could put in a company route and automatically pull up saved routes, but I don't have any stored. We'll get the runway a little bit later. And here's where you actually enter the route. Now at some point after power up, you would call for your clearance or just simulate calling up. Let's say we got a clearance and a filed route of Detroit, the Moon 4 departure, Jamestown transition, direct Hoxie intersection, then J70 to Wilkes-Barre, LVZ, then the Lendy 6 arrival to JFK. So that's our clearance. We're told maintain 10,000 initially, expect 330 in 10 minutes, squawk 6641. So copy all that down. So we want to enter the route, which we do here. Now first you start with the runway and the departure procedure if applicable, and it is here, Moon 4 departure. And you would do that with the departure arrival button. So you start at the runway, departure procedure, the route, and then a arrival procedure, and then an ending runway. So let's start with the depart arrival button. We can choose the departure information for Detroit. We would also choose the arrival information here. You can also choose arrival information for your departure airport. That's in case you had an emergency and needed to turn back. Just a quick way to do it. But we're departing Detroit, so we select depart. Along the left you have all the departure procedures in the database, and I can go to, you see there's 3 pages here. Along the right you have all the runways available. You always want to choose, well, not necessarily always, but it's easier if you choose a runway, and just listening to the ATIS and looking at the winds, I think I'm going to get 4 right. You can always change it later, and in fact it's pretty common after you push back that you need to change it, but for now we'll assume we're going to get 4 right. That will, by selecting the runway first, that will narrow down the possible departure procedures to only those that affect 4 right. So you can see our departure procedure, Moon 4 is in here, so we select the SID, the Moon 4, and we select our transition, which is Jamestown. Of course, a SID it can branch out from a runway and go to different endpoints. That's what the transition is. In our case, it's Jamestown. So we select that. Okay, now we go back to route, and we see that it's put in Moon 4 to Jamestown. After that, we're then direct Hoxie intersection. The left side is via some airway or procedure to a fix. And we're just going direct to the fix after Jamestown, so type in Hoxie. On the right side, no airway, so then it would just put direct to Hoxie. Now there's only 2 spots there, so we're going to go to the next page, and it's a nice big blank page. After Hoxie, we go via J70, so J70, that's on the left side, to Wilkes-Barre, Lima Victor Zulu. After Wilkes-Barre, the Lendy 6 arrival, so we go down to the departure arrival button. We'll pick the arrivals to JFK and the runway, or actually the instrument approach we expect. So it's going to be the Lendy 6. There's no transitions on that star. And the approach, again, you can change this later on just for sake of trying to guess which one it'll be. I'm going to say ILS 31 right. And instrument approaches can have a transition. That would be, but we're going to get radar vectored to the localizer, so we don't choose a transition. Okay, now we've done from takeoff runway, takeoff SID, the route in between, the star, all the way to the selected runway. Not done yet. You need to go to the legs page. Even though it says route, you want to go to the legs page and list out all of the fixes and double check those with the paper versions of the SID just to make sure everything's correct. So go on to radar vector to Pulry, that's all good. Weepill, Moon, Brock. Okay, that all looks good. Now here, this is pretty common to get route discontinuities. That means that it couldn't connect together, for example, a star to my main route. So you need to close those. And the way to close it is you select the one below it, and then you're going to select a point to move it to. And that's going to cut and paste. It's going to, if I select Wilkes-Barre here, it'll take this and everything below it. We're going to pull it up over the redundant one. And that's going to close that gap. So now everything's been pulled up. So Wilkes-Barre, that's correct, that's correct. Now on the star, the paper star, or the paper chart, it says to expect Lendy at flight level 190 and 250 knots. This is what this right half is for. Speed restriction and altitude restriction, if any. Now, we haven't been officially told to do that, but I'm going to do it in for pre-planning. I first put in the speed, then a slash, then the altitude. Now, if the point was cross Lendy at or above flight level 190 and 250 knots, I would put an A after that for above. If it was at or below flight level 190, I put a B. And if it's at flight level 190, I would just leave it. And that would be at. So we're going to copy that up to here. Okay, continue to the next page. LaGuardia, here's another route discontinuity. This is the ILS 31 right. These are fixes. On the paper charts, it says after LaGuardia, expect a radar vector to final approach course. For fuel purposes, you want to put in something kind of accurate to where you're going to be vectored. And I know coming into JFK from over LaGuardia, you're really high and they vector you quite a ways to the south. So we're going to enter a dummy fix. We're going to be in heading select mode after LaGuardia anyway, so it's okay that we put in this dummy fix. We're not actually going to fly over it. To enter a dummy fix, you can enter the full fix, or you can do what's called a fixed radial distance, which is a fix, a radial off of that fix, and then a distance. So I'm going to pick a point, JFK 180 at 020. That's about where they vector you. From the JFK 180 radial, 20 miles out. So let's put in that dummy fix. This will help with fuel calculation. After that, they vector you pretty much to the localizer, so then we'll just bring this up. And this is just part of airmanship and navigation. If you have no idea what I'm doing, you probably don't have to worry about dummy fixes. I want to put in one more dummy fix, though. I'm going to back up a page, and I'll show you a different way to do it. Besides fixed radial distance, you can also do an offset from a fix in front or behind that fix along the route. Now, why would you do that? Well, the Maddog autopilot isn't very good at hitting crossing restrictions. I mean, nailing it. If we just left it here, it would probably cross Lendy at flight level 19 or 2, because it kind of gets close to leveling off, but it doesn't quite make it. Now, technically, you could get called on that. ATC could say you're supposed to cross it at 19. You could lose your pilot license in real life if you bust a fix. It could be an important crossing restriction. So, again, this is just airmanship. I usually make a dummy point a few miles before that, which gives me a little buffer to slow down, because here I'll be descending pretty fast. It'll give me a buffer to slow down and also make sure I hit 19. So I'm going to pick a point 5 miles before Lendy and insert that between Stillwater and Lendy. So let's do that. Lendy, and the format is slash, and then a plus or minus, and the mileage. So I have to hit this button twice to get minus. So 5 miles before Lendy, 5 miles on this side of Lendy. I insert that between Stillwater and Lendy. It gives it a unique name. It conveniently copies in the crossing restriction because it thinks that's a common use for doing this kind of entry. And then it leaves a route discontinuity. I need to close that, so after that dummy fix, I'll go direct Lendy, so I'm going to copy up. That pulls everything up. And so there I have a dummy fix 5 miles before. That's what it'll actually aim for. It'll probably bust it, 270 knots, flight level 192, but now I have 5 miles to actually hit it. Now, with that said, there's a little bug in this Maddog version. It doesn't calculate the proper point 5 miles before. It's a little offset by, I think they confused magnetic and true north. But 5 miles isn't that big of a deal. It's just a little kink. If you're going to make a point like 30 miles before, you might want to do a fixed radial distance off of Stillwater instead of an offset from a fix. And you can see how it's kinked. From Stillwater it goes 104 bearing to this dummy fix, and then from the dummy fix 112 bearing. And it should be the same bearing. But again, that's just navigation. Our route's done. we've checked everything. Discontinuity is closed. We put in dummy fixes as needed or wanted. Now we have to activate it. Now at this point, I can erase everything I did, but executing it will actually make it official. You'll see the execute light came on, and whenever this comes on, it just means you need to hit that to officially make it, officially enter it into the system. So we're going to enter that. Now this suggests to go to route data. From there we could enter winds along each of our fixes. I don't have wind forecasts or anything, so I don't do that. Instead, after your route, go to init ref. Just remember this button here, init ref. Okay, this is where we enter our takeoff data, and we're going to go to a full screen for this. Now, the first thing you need to enter here is your fuel. Technically, the fuel you have planned once you get to the end of the runway. You can use the loadout manager program to plot a route and an altitude, and it'll estimate fuel. Or you can just use a rule of thumb. That's what I always use. This system will also calculate fuel burn. So if you're not, if your guess was off, then you can always go back and change it. But my rule of thumb is 14,000 pounds for a 1 hour flight, 4,000 pounds for each additional hour after that, which is usually a pretty good guess. And everything's in English units here, pounds. In the loadout manager program, you can go into options and change it to kilograms, but I'm going to be using pounds here. So this flight, Detroit to JFK, just looking off real world sites. I use FlightAware. It's about an hour and 15-minute flight, so I'm going to put in 16,000 pounds of fuel. Now, if you remember our loadout manager, by default I put in 18,000 and nothing in the center tanks. I'm going to change that, go up to aircraft and fuel and payload, and change fuel, and I'm just going to put in 8,000 pounds in the left and the right tanks, nothing in the center. So I need to enter my fuel. It's technically fuel at takeoff, and it's already subtracted a little, I think, for the APU. So I'm going to say 15.8. That's in thousands. And then you have to put a /A. If you don't do that, you'll get an error message. But /alpha, that goes in here. Now I can either enter a gross weight. I could just copy this in. I happen to remember my zero fuel weight from the loadout manager is 111.5. I think that's a little more accurate. But then it'll back calculate my gross weight. The reserves, this is the amount of fuel below which we'll get a low fuel warning. I usually use 3, 5 is another value you can use. Cost index is the balance between climbing up to speed quicker and going forward more slowly, or going forward more fast and climbing up to speed slower, or climbing up to altitude slower. So the values are 0 to 250 is a good one. I think real world, some of them use 15 or 10 just to save a lot of fuel, but again, we're flying East Coast US where they usually make you speed up anyway. ATC does, so I think 50 is good. Planned cruising altitude 33,000, or you can put in flight level. These fields are optional, but for fuel burn calculation, I like to put in a cruise wind, just to guess. It's better than leaving it blank. In this part of the country, Detroit to JFK at this time of year, I think it's around 50 knots, 280 at 50. And it's just a guess. It'll recalculate it once we get to altitude. Now my execute light came on, so everything looks good. I'm going to execute. Next page it suggests is my takeoff. This is the last page. First thing I'm going to do is go over to my auto throttle. This is the auto throttle mode selector, and we'll talk about this a little more. But you want to select takeoff mode, and that will tell the auto throttle, or it'll set the EPR limit, engine pressure ratio limit, which is our max power setting, to 193, and copy that into here. Those little rounding error. Okay, now I want to enter my V speeds. If you remember on our overlay selector, that little white dummy panel is your takeoff data, and the simulator will Use the runway you selected, runway conditions, takeoff weight to figure out your V speeds. So we want to copy in 127 for V1. 133 is our rotate. And 141 for V2. Now this says we're complete. Before I do that, I usually go from here and do the speed bugs. These little black things are where it says to put your speed bugs. And on your airspeed indicator over here, you see these little plastic markers. Now you can move them by yourself or move them individually by hovering over one of the corners and moving the mouse wheel. Or there's a shortcut. You can just click in the top center for your takeoff settings and bottom center for landing settings. So I click on top center, it will copy these over into my speed bugs. My V1, my V2, my flap retraction speed, and my slat retraction speed. Okay, close that out. I still want to review a few more pages here on the FMS, even though I'm complete. So I go through the climb page just to see what speed it's planning to climb at. Check my cruise. It's planning to cruise at 308 knots at 330. Once you get to altitude, it'll switch to Mach number, and usually it's Mach 77 or 78. You can override that if you want. I could put in 78 or 79 if I was in a hurry to plan on that, or I could do that later at altitude. It'll calculate fuel. It's a so-so calculation, but it'll update your planned fuel once you're in the air. Now, if this ever says 0, you probably entered a bad fix in the legs page or somewhere along the line. You know, something that's on the wrong side of the country, misspelling, or the wrong side of the planet, and it figured 0 fuel for you. But this looks about right. 7,100 pounds, and then I'm planning to descend at 290 knots. Again, I can override that. This page is optional, but again, it'll help with fuel burn. This is where you enter forecasted winds. I'm just going to put in something, 18,000 feet. I think the winds will be about 280 at 30 knots. And then it asks me to execute it. Execute. Okay, there's a couple more pages here that are used more in flight. The direct page is where you're told to proceed direct to a fix. ATC tells you, proceed direct to moon. You'd select the fix here and then copy it into the direct to, and that would amend your flight plan so that your next fix is moon. The progress page is a common status page. Once you're in the air, it tells you your next fix, your ETA at your destination, and your projected fuel at the destination. That's a good page to have. But I'm done entering FMS data. Now I'm going to set the autopilot to my initial flight plan information. So we already did the takeoff mode here. This switch is the reserve thrust or automatic reserve thrust. If there's an engine failure on takeoff, it'll automatically boost engine power in the remaining engine. That's normally left to auto, but if you're going to do a derated takeoff, which we won't get into in this tutorial, you would turn that off. But okay, so we're takeoff mode. My initial altitude and my clearance was 10,000. My vertical speed you don't use at this stage. From my departure procedure, I know that I start out on a radar vector, so just to save time, I'm going to look that up and put it in here. My speed is company policy. I like to put 250 just in case my auto throttle fails. That gives me the little bug to show me my speed limit of 250 below 10,000. Depending on your route, you could put in something on the nav radio so you can maybe get a DME fix. And that's the initial autopilot. Then I come down here to the center console, and you remember from the overview, this is where I put in the center of gravity calculation from the loadout manager, but it pre-programs it for you, 21. I dial it here. I'm planning on 15 flaps, so it calculates. This is my trim setting, so I'm going to actually trim up and set that at this point. Now you hear that buzzing. Get used to that. That's the warning that the trim is moving kind of fast. And the autopilot will move it fast sometimes too. So it's normal to hear that in flight. And of course I was moving it fast to get to my takeoff trim setting. You can arm your speed brakes here if you want. By default on FSX, it's shift slash. You're going to have to arm it anyway before takeoff. And we were given a 6641 code. So I'm going to program that in now. And you can put your auto brakes on takeoff and then arm them. If you put them on takeoff and didn't arm, you'll see a little caution light here. So I'm going to arm it at this point. Or you could do that during the taxi, but with only one pilot, it's easier just to do it now. So that is programming the FMS and the initial autopilot settings. At this point, you're ready for pushback and start. All right, I've pushed back already and set the parking brakes. Now I'll do engine start. And we're using the APU to start. First start at the overhead panel. Now the starting system is air powered. So the idea is we're using air from the APU. That's why we had to turn the air on. We use that air pressure to get the jet engines spinning. And once they hit a certain point, we turn on the fuel, and the igniter will then ignite the fuel, and that's what starts the engine. But it is air powered. And because it's air powered, we have to turn off the cabin air before we start it. Now you notice this pneumatic pressure or the air pressure is not yet enough to start it. It's in the warning zone. If we turn off cabin air, you'll notice the pressure now goes up much higher, so the starter has enough to start. Okay, so overhead you just turn these two off. Then I bring up the mini panel and the center pedestal. And you want to move the center pedestal over enough so you can see the N2, because you have to look at that to know when to turn the fuel on. So this mini panel is so you can start it more easily instead of toggling back and forth. So you want to turn your pumps on. I have no fuel in my center tank, so I can leave those off. My igniter, you have to turn to A or B. Yeah, that has to be on. And then the starter switches, take off the plastic covers, and we're going to start it. Now, what we do is hold down the switch, and as we hold down the starter, the N2 will spool up. When it gets to 20, we'll then push this lever here. This is the right engine fuel up, and that'll fuel it, and once that's pushed up, the starter will ignite. And then we'll do the same for the left engine. Now, there is an undocumented trick to do this correctly. And the reason is these little switches are momentary. So as soon as you let go of the mouse, it flips back off. And then you start spooling down. So it can be really frustrating if you don't know this trick. The trick is you're going to click the starter, drag, while you're holding the mouse button down, drag it off that little window, and then let go. And then the button will stay. Then you can come down here, watch it, and move the fuel up. So that's a trick. Okay, we've got our starter on, our fuel tank's on, our air is off, our cabin air is off, so we have enough pressure. So I'm going to drag it down, drag my mouse off that window, and let go. The switch stays down. Now I'm going to let this spool up to about 20. Once it gets to 20, I'm going to take this white dot, this fuel lever, and push it forward. Okay, push it forward. I now have fuel, and it should catch. And there it goes. Now I come back to the starter switch, click it, it turns it off, and turn it off. That ding was the electrical system switching over from APU to the main engine. Now remember, we had the master switches on for the engine generators. That's why it did it automatically. Remember the priority, this is first priority, second priority, so you can see this light turned off. The right bus is now powered by the right engine. Left bus still by the APU. Okay, that aside, let's start the left engine. So same process, click, hold the mouse button down, go off the window, let go. I'm going to watch N2 spool up. With my hand on the fuel lever, it hits 20, push it forward, and there it catches. Okay, turn the starter off, close the cap. You turn this to both, which is continuous ignition. Okay, close those windows. Go to the overhead, not done yet. Now there's a mini flow. We're going to go top to bottom here and then cross over. The generators are online. APU we can take offline even though they're not powering anyway. Turn the APU off. Turn the air off. And along with the APU switch, its fuel pump goes off. These are all on. You got to come over here. This is probably the most important thing of the entire flight. Turn the cabin air back on. And the reason is you'll never pressurize. You'll climb above 10,000 feet, your cabin altitude, you'll get a warning. Oxygen mass will fall, people will start dying. So you got to always remember to do that. And likewise, if you ever hear that cabin alert or cabin altitude warning, that's probably why you forgot to turn these on. And then I continue down here and lock the cabin door, although it doesn't really matter. And there I'm started. Now, there's a lot of times where, or at least when you're new to the aircraft, at least it happened to me, you set everything up and you hit the starter and nothing moves here on N2. The things to check are, make sure you turn the igniter on. I use B. Make sure the fuel pumps are on. And make sure the air is correct. Remember, it starts with air. So make sure you've turned off the air supply to the cabin and also double check that the APU air is on. So APU air, cabin air, starter, and fuel pumps. It's usually one of those things when it doesn't spool up. If you just can't figure out why it's not starting, I would suggest do a full flow. Go back to that section where we checked all the switches because there's a lot of things that you might have forgotten. For example, the crossfeed. If these are down, you forgot to put those up, it'll never start. Why? It's just how the air is routed through the aircraft. And now we're starting. What I do at this point, and you can do it while you're taxiing, but with a single pilot operation, I usually at this point I'll set my flaps. So I'm going to hit 3 notches. It goes up to flaps 15. Remember, the notches are 0, which is slats, then 11, then 15. And then I go right to left here, go across. You have to click between here. Now I'm going to move this over. You click between the throttles. That's the takeoff mode. And you'll notice this annunciator goes to takeoff. Continue across, make sure my speed brakes are armed, which they are. I come down here. At this point is where I turn on my TCAS, T-A-R-A, even though you normally wouldn't do it till the runway. Check my auto brakes, those are all good. And check my trim setting is correct. All right, we've taxied and gotten into position on the runway. So I'll turn my landing lights on. But we're just going to sit here for a little bit as I discuss the auto throttle and the autopilot. I'm also going to engage the brakes. First of all, when you advance the throttles at takeoff, it's possible you could get a configuration warning. And it sounds like this. I'm going to get the warning because my parking brake's on, and I'm going to move the throttles forward. Okay. It sounds like that, and it'll announce what's out of configuration. So that's my parking brake. If it's not the parking brake, it's going to be something on the center panel that's not configured correctly, the center pedestal. So if you get that alert, you're not sure what it is, check your parking brake and then check this pedestal. That trim is set in the green area, your auto spoilers are armed, your flaps are set to the pre-programmed value, and if you have auto brakes installed, it's on takeoff mode and they're armed. Those things can trigger the configuration alert. Now, assuming everything's configured correctly, the process to set your takeoff power is to physically advance the throttles. If you have physical throttles like I do on my desktop, you want to go a little over halfway, about 60% setting. That will start spooling up the EPR, which is your power setting. The takeoff power setting is shown up here. Now the process will be once it gets past about 1.4, you're going to flip on the auto throttles. And at that point, the auto throttles will continue moving forward to the power setting, the proper power setting. However, the auto throttles in the Maddog are a little different than other aircraft. Most other aircraft, you can either be in manual mode where it's complete, you control them completely, or it's auto mode where the computer controls it. These auto throttles are, although it's called auto throttle, it's still in partial manual mode, which means that even though it'll advance the throttles, it'll still look for your input if you have any input. So you can kind of nudge them forward if they're not going up far enough. You can pull them back a little bit if they go a little too far. That's just one of the quirks of the Maddog, that the throttles aren't exact. So when I push the throttles forward, gets past 1.4, turn on auto throttles, you still might have to physically tweak your throttles until the power is set properly. It's possible to go past it, in which case these will start blinking that you're overheating. If you don't advance them far enough, it'll be a little short. You're going to have to nudge them forward. So it does take a lot of extra attention to get it set just right. Okay, before we do that, let's first talk about rejected takeoff. If you advance the throttles, click on auto throttle, you're accelerating nicely, your power's set, but before V1 you need to abort the takeoff. Remember this, you have to disengage the auto throttle before you pull the throttles back up. If you don't, if all you do is pull the throttles back, the auto throttle is going to push them back forward. So to reject takeoff, disconnect auto throttle, pull the throttles back, and hit the brakes. At that point, your auto spoilers will deploy, and you should come to a stop. Okay, so that is setting power for takeoff. Once we rotate at VR and begin climbing, you'll want to pull back to an initial pitch of about 7 degrees. It should take about 5 seconds to get to that level. That's so you don't tail strike. And then once you get to 7 degrees, you can continue pulling back a little further until about 15 to 18 degrees. That's going to be your normal climb pitch. Now, there are 2 power setting events or autopilot events. The first will happen at 400 feet on your radio altimeter, so 400 feet above ground. You're going to push 2 buttons. You're going to push one of the L nav, so it's either going to be heading select or nav. If at 400 feet I'm going to be on an assigned heading, I'm going to pull heading select. If at 400 feet I'm going to be on an RNAV route, following a magenta line, I'll push nav. So one of those 2 plus EPR limit. And that's going to set the flight director to follow you properly and also stay on takeoff power. Okay, so once again, 400 feet, either heading or nav, depending on what mode you're going to be in at 400 feet, and EPR limit. Okay, you're going to continue climbing. At 400 feet, you could start your initial turn if the assigned heading's different. In our case, it's going to be runway heading, so we'll just keep flying straight. At 1,500 feet, 1,500 feet, again on the radio altimeter, and it could be a little more, it's rough. You're going to hit 2 more buttons. You're going to come over here and press climb to go into climb power, and you're going to click VNAV to turn on vertical navigation. At that point, your flight director will be accurate for both pitch and for heading, so you can follow that. At 1,500 feet, when you click VNAV, it's going to suggest you nose over to about 10 degrees pitch and accelerate. And you're going to watch your bugs to see when to retract flaps and when to retract slats. Okay, so we're going to begin the takeoff. Again, first event's at 400 feet, 2 buttons to press. In our case, it's going to be heading and EPR limit. At 1,500 feet, 2 buttons to press, climb power and VNAV, and then we'll just continue flying as necessary. You can turn on the autopilot whenever you want. I usually wait till I've climbed a little bit more. So let's begin the takeoff. We checked our configuration. Everything is set as far as we know. This is indicating warning lights, but again, it's just this graphic. If we actually look at the real one, the only warning is parking brakes on. So we'll take the parking brakes off and lights go out. We should be able to begin our takeoff roll. So I'm going to advance the throttles slowly up to about 60%. Wait until I hit 1.4. Click on the auto throttle.
Takeoff thrust set.
My co-pilot says the power's set. So yeah, it's right about right at the limit, so I don't have to nudge it.
Clamp.
Clamp's a normal call out.
80 knots, cross check.
Double check the 80 knots.
V1. Rotate.
I'm going to pitch up slowly to 7 degrees. Now I'm going to continue up to about 15 to 18.
Positive rate.
Put my gear up. Adjust my trim so I can hold it. First event's at 400 feet. It's coming up. 2 buttons, heading select, and EPR limit.
Gear up. Lights out.
And this is my auto throttle. It's in takeoff mode, so that's correct. I'm still in heading select mode. I'm past my flap retraction, so let's put the flaps up to flap 0. Slat's still down. 1,500 feet, 2 more buttons, climb, and VNAV.
Flap 0.
And it's suggesting I pitch down to 10 degrees. To accelerate. Okay, slat retraction. Slats go up.
Slats retracted.
Now I begin my climb. Now
Climb thrust set.
I'm trimming down, so you hear the trim warning, but that's fine. And here I'm just following whatever ATC tells me. Maybe they say fly heading 060. So I'm flying manually. Also dialing it in. My flight director will direct me there. I'm watching my speed, etc. Okay, it's a little later in the flight. I've turned on my autopilot. Now this contraption here is your autopilot mode. So in other aircraft, it may tell you you're in nav mode or heading mode with a little light by the button. Here it tells you here. So this is your speed mode. You want it to say FMS, flight management, so that it's on the auto throttle. Here's my lateral mode. I'm on heading select. I'm still on the assigned heading of 060. And I'm in VNAV climb, meaning that the which is what you want it to be, the computer's adjusting the climb rate automatically to hold my speed and for my power setting. Now I'm looking at my power setting, so you got to pull it back a little bit. It's going a little fast. Okay, so that looks good. Now at 10,000 feet, which is what I was assigned, let's say I was told to continue climb, maintain, flight level 330. Dial it in, click it to arm. Now once it gets to 10,000 feet, it's going to nose over, increase to climb speed, and then automatically, once it reaches climb speed, it'll continue the climb. Okay, now even though I put in flight level 330, it's decided to still level off at 10,000. So I need to give it a little kick by going into manual vertical mode. And this is part of why they call it the Maddog. You dial in an altitude, it decides to level at some other altitude. In this case, it was the previously set altitude. So you kind of have to monitor that continuously. I gave it a little kick by switching into vertical speed mode by just adjusting it manually. Once it got past 10,000, I'm going to go back into VNAV mode. Now the auto throttle and VNAV are closely related. So if I dialed in a new speed, let's say ATC said to maintain 320 knots or greater for spacing. If I went into speed select mode, it's going to kick me out of VNAV mode. And I don't want to do that. So anytime you get an ATC assigned speed, you use FMS override. So let's do that. I'm assigned 320 knots or greater. I click FMS override, dial up to 320. If I wanted to go faster, I could do that. Because I'm still in VNAV mode, it's going to adjust my pitch to speed up to 320. And that'll show here. Now, since I've overridden the FMS for the speed, when I'm told to resume normal speed, I could look at my climb. I could see that I was planning on 306 knots. And I could click FMS override again, and it'll go back to 306. So I'm back on the original FMS plan speed. Okay, now here we see an MCDU message, and you may have glanced at before. That means there's a message on here, insufficient fuel. So it's calculated that we won't have enough fuel, or at least we'll have fuel below our reserves. You can see here it thinks we'll have 1.0 or 1,000 pounds at Kennedy. All I can say is the fuel calculation isn't very accurate until you get to altitude. So it's kind of assuming that we're going to stay at this altitude at this speed for the whole flight, which isn't correct. So you can just ignore that message. And it should eventually go away anyway. To get rid of this, you have to choose a page where you can enter data, like the legs page, and then click clear. Okay, a little bit later in the flight, we're still on an assigned heading, and let's see how to put in direct to a fix. So say air traffic control told us proceed direct Jamestown. You go to the flight management computer, direct page, find the fix that you were cleared direct to, in this case Jamestown, JHW, select it, that puts it in the scratch pad, and then select this field here, direct to copy it in. It's not active until you hit execute, and you'll notice it put a proposed course, suggested course. I could erase it if I didn't like it or I picked the wrong one, but let's do it again. I'm going to go direct to Jamestown, click execute. My magenta line now adjusts, my route fixes, but I'm still on an assigned heading, so I got to go to nav mode. And you'll notice it switches from heading select to nav track. It's now going to turn to join the magenta line. Now you'll also notice at this point that it's selected a different speed for the climb. I'm not sure why it does that. Sometimes it does, sometimes it doesn't. It has its reasons. Again, it's why it's called the Maddog. Now you'll notice on the horizontal situation display there's a green TC. That means the top of climb. But if we zoom in, which you can do by holding the cursor over it and using the mouse wheel, or using this control, but for me the mouse wheel is easier. This is the computer projected top of climb when we'll be at our selected altitude. The green arc here is called a banana. That is where it projects will be at the selected altitude at our current rate of climb. But this is going to vary as we get higher up and it gets harder and harder to climb. So that's not always accurate for top of climb. If we were descending, you can use this to project where you're going to be level. That's usually pretty accurate. Okay, now let's do an assigned heading. So we're on our magenta course line. We're in nav mode, flying along on autopilot, and ATC says for traffic, fly heading 070. So we go in here, we dial in 070. I'm using the mouse wheel. You can also click. Oops. So you dial in 070 and then click on the center, and that puts you into heading select mode, and you begin turning to that 70 heading. Now, on this part of the HSI, you can see a little white triangle. That's your magnetic heading, and the magenta diamond, which happens to coincide with it, is your bearing. So of course at high altitude where you have a strong wind, your magnetic heading could be different than your bearing, but that's what those two are. When you're told to turn to a heading, you want the magnetic heading indicator to line up with the selected heading here. And autopilot looks like it's doing that just fine. All right, we've almost reached our cruising altitude of 33,000 feet. I've gone back to FMS speed, and at this altitude it switches over to show you what it's planning to do in Mach number, almost 0.77. That's the altitude warning that we're almost at 330. Now sometimes, depending on your weight, we had no problem here getting up to 330, but sometimes it'll really dog it, and ATC needs you to maintain at least 500 feet a minute. Sometimes you may, in that case, need to force a vertical speed of at least 500 feet a minute. If you do that, then it's going to switch into the mode where it's holding the present speed. You're manually controlling the vertical speed, and you have to be very careful that you monitor your altitude. Sometimes it'll level off at your selected altitude, other times it'll bust right through it. And there it's saying altitude capture, altitude hold, so it's going to level off. If it kept saying vertical speed and it was you're 100 feet away from it, that means it's going to bust through it. You're going to have to level off manually. All right, a little later in the flight now, we're approaching our top of descent, where we will Begin descending for our ATC assigned altitude, which they haven't given us yet. Throughout the flight, you have to monitor the speed. It'll get a little faster, slow. Again, you got to kind of nudge the throttles. Watch that it doesn't get too far beyond. So right now we're a little bit slow. I'm nudging them forward a little bit. But before the top of descent, you want to do your approach briefing, whatever your normal process is. But part of that is going to the FMS and clicking on init ref. Now remember, we did that for takeoff. We're also going to do it for landing. First, we get this message, reset the altitude. That means we're coming up on the top of descent, and we should be dialing in the new altitude. So here ATC would say cross Lendy at maintain flight level 190, 250 knots. So we would go to legs, we'd find Lendy, and remember we put in that dummy fix a little before it, which is fine. You can do that legally. So that's programmed in. So we're going to dial in 19,000 and arm it. You'll notice the message went away, and when we get to the top of descent, it's going to begin descending. But back to the takeoff briefing, I'm sorry, the landing briefing. Besides reviewing the approach, you've got to press init ref, and you'll notice it says approach ref. You need to select one of your flap settings, landing flaps. Normal's 28. You could do 40 if it's a short runway or you need to be slower, but 28's fine. So you click it, and this will give you your runway information. If you remember back before we took off, we guessed it would be 31 right. You could change it if the runways change, select a new instrument approach, but from what I've heard from the ATIS, we should still expect 31 right. So this will tell me my ILS. I should really confirm it with paper charts, but I'm just going to go off of that. And a course of 314. And I can use the mouse wheel or click up and down. And there's my runway information. Okay, so my approach briefing is complete, and I'm just about to start the top of descent. This pops up once we do, and it'll begin descending. Now you have to watch the speed. Sometimes it's not very good pulling the throttle back, so you got to help nudge it that you don't overspeed. So speed looks good. We see our banana showing where at this rate of descent where it expects us to level. And zooming into the route a little bit, that's Lendy, and then this is our fake point, Len 02, so it looks like it's going to level around Len 02, which is our 5-mile buffer we put in there. So you just have to monitor it as it descends. You'll notice it's in VNAV descent mode. If the VNAV wasn't doing very well with the descent, you're either too fast or slow, or the banana shows you're going to miss your crossing restriction, you can come up here and switch into manual vertical mode, adjust your vertical speed, and you notice you go into vertical speed mode, and the auto throttles are just going to hold the 288 speed. And then as I adjust this up and down, you'll see my banana adjust. Looks like I have a little buffer room, so I'm going to shallow up the descent a little bit. And once I'm comfortable with that, I might go back to VNAV mode. Okay, a little later now, we just passed our dummy fix where we put in the 250 knots, flight level 190. It hit the altitude, 19,000, but the speed was still a little fast, so it's a good thing we had that dummy fix. Okay, at this point in the flight, we'd normally be switched over to New York approach. When you're descending in approach control airspace or in the approach phase of the flight, you don't want FMS to do it. Because in approach control, they're going to descend you, also adjust your speed sometimes, or usually. And the FMS is not very good at doing that. Also, when they tell you to descend, they need you to descend right now. The FMS likes to stay level. It's just kind of quirky. So we're going to go into manual vertical speed mode once we're told to descend. Here ATC would tell us after Lendy fly heading 180, descend and maintain 1000. So we'll turn to 180 heading, dial it in, select it. We go into heading select mode, go down to 1/1000, arm it, and we're going to manually do vertical speed. Now, the normal rate of descent in approach control airspace is about 500 to 800 feet a minute. And that will allow you to also slow if you need to. You can descend at about 1,000 to 1,200 feet a minute and hold your speed, but you can't also slow. And this is just airmanship, switching off vertical speed and your ability to slow down. Just from my experience flying in this airspace, it's okay to descend at a fast rate. They're not going to slow me until I get closer to, until I get to a lower altitude. So a little bit later now. One thing I forgot to do in the approach briefing and in the init ref was to set my landing speed bugs. And you remember the shortcut, there's a click spot on the bottom. This will set your takeoff speed and your landing speed bugs. So the first one is your first notch of flaps, flaps 11, 15, 28, and then there's my VREF, for the speed I want to be over the threshold. Now we have an MCDU message, so let's pull up the CDU. It's saying that drag's required. I'm going to clear that out. Go to the legs page, clear it out. And it won't let me do that. What that's saying is it can't hold 250 knots and also this rate of descent. So I'm going to shallow out my descent a little bit instead of using speed brakes. Now let's say at this point ATC tells us to reduce speed to 210. I definitely don't want to be descending at 1,200 feet a minute, so let's shallow it out a little bit. Select 200 knots on our speed, or 210 knots on our speed, and you'll notice that the speed portion of the autopilot says alpha speed. This means it's not going to reduce the speed because it thinks we're going to stall or we don't have the lift. That's probably because the Maddog's wings are stubby. Anytime you're below 250 knots in the descent, you should have slats extended. So let's extend our slats.
Extended.
And it goes into low limit mode, which means the throttle's all the way back. And you can see I'm slowing down. When I get to my first flap speed, I'm going to go flaps 11. Close enough. Flaps deploying to 11. And I'm slowing down nicely, so I'm going to increase my rate of descent. And you pretty much just continue this until you're lined up with the runway. And if you continue to slow beyond 210 without your landing gear deployed, you'll get a landing gear warning. On your center console, you can cut off that warning with this. It doesn't last very long, though. It's very annoying. It's just part of the Maddog aircraft. You can deploy your landing gear early if you want. Now let's say at this point ATC turns us to a 140 heading. So I'll dial that in. I'm already in heading select mode. So it starts the turn. And they slow us to 180 knots. There's my landing gear alert. So I'm going to silence it. That happens anytime you're below 210 knots and your throttle's idle. So you can bump up the throttle a little bit, and that will keep the warning. It'll silence the warning. All right, a little further along, we're about to intercept the final approach course to runway 31 right. We're right on the glide slope, and it's identified, and our localizer's alive, or we'll intercept it. This is the final approach course. The autopilot buttons work similar to other aircraft. You can just intercept the localizer by pressing this button, and we'll go into loc mode. Once localizer's been captured, it'll say loc cap, and then it'll turn to intercepted. If you want to intercept both the localizer and the glide slope, in other words, cleared for the ILS approach, you click ILS. There's also an auto land function. I usually fly it by hand after I'm past the last fix. Now, we were assigned 180 knots by ATC. We're a little bit slow, but we're right at the next flaps, so I'm going to go up to 15 flaps now.
Flaps 15.
Monitor my speed. I was told maintain 2000 until established, cleared ILS 31 right. There it's captured the localizer. Turns to intercept, a little below the glide slope. Let me adjust my vertical speed.
25.
And there comes the runway in sight. So here we pull into the gate. The APUs I've already turned on once I came off the runway, and I've already switched it online. You can see the APU's online there. So as soon as I power down, it's going to switch over to APU power. So I want to bring up my center pedestal, and when I park, set my parking brakes, and I'm going to pull the fuel levers. Those are these two things off. And that shuts down. Those dings are the power switching over to APU. So my power is continuous, APU air is on, and that's it. I'm now ready for the next flight. And that's the basics of how to fly and program and operate the Maddog.